Hello, my name is Lait Nurhan. I'm an undergraduate research assistant at the Institute of Smart Systems and Artificial Intelligence. This is the second part of the tutorials on speech command recognition, data generation. In this video, I'm going to talk about the augmentation techniques. To increase the dataset size further, we applied audio augmentation techniques, such as time stretching, pitch shifting, and adding background noise. In this regard, we used Librosa and Audimentation's Python libraries. After having text commands, we applied time stretching. Time stretching is a process of altering the duration of an audio signal without changing its pitch. Next, pitch shifting was applied. Pitch shifting is a technique used to change the perceived musical pitch of a sound, making it higher or lower in frequency. We employed the ESC50 dataset for the background noise component, which consists of a collection of 2000 environmental audio samples categorized into 50 semantically distinct classes. And finally, we received our augmented command. As an example, the log spectrograms of raw audio signals before and after augmentations are shown in Figure 1. It can be seen that the raw audio signals were stretched and merged with randomly selected background noise signals. So now, let's move to the coding. For this tutorial, we will work with data augmentation file. First, we need to import the required packages. Next, we are defining sample rate, duration, and rates for different augmentation techniques. Also, we are using only one background noise. Next, we are defining paths to synthetic, extracted, and the background noise datasets. You can download the background noise from that link, then we need to create a path to save the augmented speech commands. The original background noise files are 44.1 kHz, while our speech commands are 16 kHz. It's recommended to change the background noise files to 16 kHz to make augmentations faster, however, you should do it only once. Next, we are defining augmentation functions. To add white noise, we are sampling noise from normal distribution. Then by noise percentage factor, we are making sure of how many noise we would like to add to the audio. The same with time stretch and pitch scale. As an additional augmentation, we also add random gain and inverse polarity. Gain is typically adjustment of tone of the sound before it gets processed. When an audio signal is inverted in polarity, the positive and negative amplitudes of the waveform are reversed. This means basically that the parts of the waveform that were originally positive become negative, and vice versa. Next, we are looping over WAV files and loading the WAV file, then looping through time stretch rates and applying time stretch augmentation to the raw signal. After that, we need to loop over pitch scales and apply pitch scale augmentation. We also need to make sure that the audio length is 1 second. Therefore, we are adding silence if it's less than 1 second, and if it's more than, we are stretching the audio to make the length 1 second. Then we need to save the first augmented file and apply Gaussian noise and save it again. The same with background noise. For this tutorial, we applied only one background noise, however, you may apply more than one. Let's play some of the speech commands.
Arka. 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 Alga. Alga. Alga.
In the next tutorial, we will talk about the collecting testing data. Thank you for watching.